Hey, we ready? We're skipping the do now. So now we quiz 10-1 to 10-4. So remember I said we're doing 3 little quizzes, right? We're not going to have a big test in this chapter. It's going to be 3 quizzes on 3 sections each. So we're now going to do 10-5. We're going to actually spend 2 days on 10-5 because there's a lot of formulas. So one day we'll learn the formulas. Next day we'll practice the formulas. All right, so the formulas come down to 3 categories. It's all based on angles. If the vertex of the angle is inside the circle, outside the circle, or on the rim of the circle. So I always say inside, outside, or on. So is the vertex inside the circle, outside the circle, or on the rim of the circle? Now we know one very special angle that has its vertex inside the circle, and that angle is called the central angle. What's so special about the central angle? The vertex is where? At the center of the circle. So a central angle is an angle whose vertex is at the center of the circle. And now what do we know about the central angle and its intercepted arc? They are the same. So if my central angle is if my intercepted arc AB is 60 degrees, my central angle is also 60 degrees and vice versa. So the first example, I'm saying if arc AB is 50 degrees, what is the measure of angle AOB? 50. Hey, but now be careful. Now they're saying arc BCA. What is arc BCA? The major arc or the minor arc? Major, so it's from B to C to A. So they're saying this major arc is 275. Now we want to find angle AOB, which is this angle right in here. Well, is the central angle the same as the major arc or the same as the minor arc? The minor arc. Any ideas on how I can find minor arc AB? Lexi? You got it. 360 minus 275. So we're going to be at 85. So if the minor arc is 85 degrees, the central angle is also 85 degrees. All right, so that's the central angle. Now we're going to talk about angles with vertices on the circle. When I say on the circle, it means the pointy part of the angle, the vertex of the angle, is on the rim of the circle. A blank angle is an angle whose vertex is on a circle and whose sides are determined by 2 chords. This is called an inscribed angle. You will need to know their names eventually. An inscribed angle is an angle whose vertex is on a circle and whose sides are determined by 2 chords. So if you notice at our diagram to the right, we have angle, I don't know what that's supposed to be, maybe an H, right? So we have angle HKM. The vertex of this angle is K. It's on the rim of the circle. The sides of the angle are 2 chords. So KH is a chord, KM is a chord. That's always what what an inscribed angle looks like. Its vertex is on the circle. Its sides are chords. The next type of on angle that we have is called a tangent chord angle. Now, guess what? A tangent chord angle is made up of one side of the angle being a tangent segment and the other side of the angle being a chord, and its vertex still lies on the circle. Now, looking at my first diagram on top, which arc is intersected by angle HKM? Which arc is intercepted by angle HKM? So when I say intercepted, I mean the angle's a Pac-Man mouth and it's eating an arc. Which arc is it eating? Jeff? HKM. HM. Do you see Pac-Man mouth eating this arc? All right. Which arc is angle RQP intercepting? Which angle is RQP? Again, the angle's a Pac-Man mouth and it's eating an arc. Which arc is it eating? Joe? QP. Do we see that? This is an important question because it's going to play into our formulas. Okay? Okay, so how do we find the measure? How do we find the degree of an on angle? So the way we find it is angle is going to equal arc divided by 2. You could say arc degree if it makes you feel better. So the degree of the arc divided by 2. So for example 3, AC is 112 degrees. I want to find angle B. So you look at the vertex, and I'm going to ask you, the vertex of this angle, is it inside the circle, outside the circle, or on the rim of the circle? Inside, outside, or on? How many people say inside the circle? How many people say outside the circle? How many people say on the circle? This is absolutely on the rim of the circle. So remember, the formula for an on angle is going to be angle equals arc divided by 2. And the arc I'm talking about is the intercepted arc. It's the arc that the Pac-Man mouth is eating. Which arc is the Pac-Man mouth eating? AJ? AC. So this is going to be angle equals 112 divided by 2. So that is going to be 56 degrees. So angle B is 56 degrees. So example 4, we have FE is tangent at E. Angle DEF is 56 degrees. Now this time I'm asking you to find arc DE. So I'm asking for this arc. Do we all agree angle DEF is an on angle? Its vertex is on the rim of the circle. Since it's an on angle, we're going to use the formula angle equals arc divided by 2. But this time I'm not given the arc. This time I'm giving the angle. So in my formula, let's bring it up top. I'm going to have 56 degrees equals the arc over 2. And I want to solve for the arc. Since I want to solve for the arc, I'm going to multiply by 2 on both sides. So now I'm going to have arc is equal to 2 times 56, which is 112 degrees. So these formulas can go either way. They can help you find an angle or they can help you find an arc degree. All right, so those are the on angles. Now we're going to talk about angles that are inside but not at the center. Because if its vertex is at the center, doesn't that make it a central angle? So now we're inside, but our vertex cannot be the center. The only type of angle we have for that is called a chord angle. And a chord angle always looks like an X, but never at the center. A chord angle looks like an X, but never at the center. All right, the formula for inside but not at the center. A vertex inside but not at center. You're going to have angle equals arc 1 plus arc 2 divided by 2. And you'll understand what I mean when we actually do a problem. Are we ready? Okay, so here we have arc DF is 60 degrees, and we have arc CE is 170 degrees. We want to find angle CPE. I'm going to call it angle 1. That's what we want to find. Is angle 1 a central angle? Yes or no, and how do you know? Is angle 1, the angle of CPE, the angle we want to find, is that a central angle? Yes or no, and how do you know? Nora? Excellent. No, because the vertex is not at the center point. So do we all agree this is just a normal old inside angle? So our formula is going to be angle equals arc 1 plus arc 2 divided by 2. Now, my arc 1 is going to be the arc that the angle intercepts, or the arc the angle is eating if you're looking at it like a Pac-Man mouth. Isn't this angle 1? So which arc is angle 1 eating if it were a Pac-Man mouth? Hum, 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 hum. Big meal CE, right? So we're going to say arc CE. I'll write it out in words first. All right, now we need another arc because I wrote arc 1 plus arc 2. Do we see how there's an angle vertical to angle 1? And aren't vertical angles congruent? Yeah. So let's look at angle 2, the vertical angle to angle 1. And now I know angle 1 and angle 2 are congruent. Which arc is angle 2 eating? DF. There's that meal. So we have arc CE plus arc DF divided by 2. So now we're going to have angle 1 is equal to 170, which is arc CE, plus 60, which is arc DF, divided by 2. So angle 1 is going to equal 230, thank you, divided by 2. So angle 1 is, I don't know, 115? I'm going to believe you. All right, so here we are, angle CPE is 115 degrees. All right, recap of some definitions. What is a line that intersects a circle at exactly one point? Anybody remember what that's called? A line that intersects a circle at exactly one point. A tangent. So that's an old vocab word. Now a new vocab word. A blank is a line that intersects a circle at exactly 2 points. That could look something like this. Basically, it's a chord extended into a line. This is called a secant. So a secant touches a circle twice, a tangent touches a circle once. All right, so we did vertices inside the circle, we did vertices on the circle. Now we're going to do vertices where? Outside the circle. Angles with vertices outside the circle. The first type of angle we have is a secant angle. Do you see how it's two secants meeting at a single point? That's the first type of angle we have, secant. What do you think this next angle is going to be called? Good job, Nora. Secant tangent. What about the last angle? What do you think that is? Good job. Tangent. All right, so know the formula for vertices or vertex outside the circle? Are we ready for the formula? Angle will equal big arc minus small arc divided by 2. Do you think you need to memorize these formulas? Yes. Are we ready? Okay. So we want to find the measure of angle A. What I'm going to do is I'm going to trace angle A all the way through. And when I trace angle A all the way through, I notice it intercepts 2 arcs, or if it were a crocodile mouth, it's eating 2 arcs. What 2 arcs did it intercept, or is it eating? Kaylee? You got it, BE and DC. All right, so my formula, do we all agree A is outside the circle? Its vertex is outside. So the formula is angle equals big arc minus small arc divided by 2. Which is the big arc here? 100, yep, minus our small arc, which is 20, divided by 2. So angle A is going to be 80 divided by 2, which is 40 degrees. All right, so now can somebody tell me what kind of angle is number 7, if we had to name it? AJ? Good, it's a secant tangent angle. So now I need to look at the 2 arcs it's intercepting, or the 2 arcs it's eating. I think the first arc's pretty simple. Do we all agree that it's eating arc KH? The other arc it's eating is not 100 degrees. It's not eating that 100. Its mouth is going right over that 100. Didn't open wide enough for the 100. Right? So what's the other arc that it's eating? Name it with 2 letters. Dimitri? JK. I don't have a measure for JK, but I can find the measure for JK. Doesn't a full circle have to add up to 360? So I have 100 plus 60, which is 100 plus 60, which is 160, which means how many degrees left over? 200. So now we know angle F will be big arc minus small arc divided by 2. So angle F is 200 minus 60 divided by 2. So we have 70 degrees. Very good. All right, number 8. What kind of arc is number 8? Good. This is a tangent angle. All right. Now, you know what? I'm just going to tell you the shortcut now. The tangent angle and its arc add up to 180. Tan angle plus arc equals 180. What does that mean? If the arc that it eats is 100, the angle has to be 80. All right, let's do some mixed practice. All right, the first one, so now it's not going to be so straightforward. So the first one we want to do is find angle Y. This point right here is the center. So is angle Y a central angle? No way. So we know it's an inside angle. The problem for the inside angle, it's arc 1 plus arc 2 divided by 2. But arc 1 is this one, and arc 2 is this one. We don't have any measurements for those, nor can we find measurements for those. So now we have to think outside the box, meaning it can't be so straightforward. Now I'm looking at the two arcs I do have. I have this pink arc and I have this purple arc. So if I wanted to, do you see angle 1 over here? I can find angle 1 using these two arcs. Now what's the relationship between angle 1 and Y? They're supplements. So if I find angle 1, can I find angle Y? Absolutely. That's what I mean when I say think outside the box. So now I'm going to say angle 1 is equal to arc 1 plus arc 2 divided by 2. So angle 1 is equal to the arc that angle 1 eats, which is the 29 degrees, plus the arc that its vertical angle eats, which is 47, divided by 2. Is this 76 over 2? Does that sound right? Which is 38. Is that Y? No, sir, it is not Y. What is Y going to be? Y is going to be 180 minus 38, which is going to be 142 degrees. Are we ready for number 2? Okay, so now what are we doing? Now I'm finding an arc. The angle they gave us is inside but not at the center. Now the arc that was given, does that correspond to the 72? Yeah. The arc that we want to find, does that also correspond to the 72? Yeah. So we can use the inside formula. Angle equals arc 1 plus arc 2 divided by 2. But be careful. That 72 is not an arc. What am I substituting that 72 in for? What does that 72 represent, Joe? The angle, so it's going to be 72 equals my first arc, which is 21. What's my second arc? Y divided by 2. And now we solve. I'm going to go ahead, I'm going to multiply by 2 on both sides. So I'm going to get 144 equals 21 plus Y. Subtract that 21. And I get Y is equal to 123 degrees. All right, given circle P. P is the center of the circle. DB is 20. And DE is 104. Now we want to find angle C. It's this angle. Angle C, inside, outside, or on? Outside. Who remembers the outside formula? Anybody remember the outside formula? Kaylee? You got it. Angle equals big arc minus small arc divided by 2. So we're trying to find angle C. Now, one arc is definitely 20. Can somebody tell me what's the other arc angle C intercepts or is eating? What's the other arc? Demetri? EA. Hit a little bump in the road. What's the bump? What's the problem? We don't have a degree for EA. Any ideas on how we can find a degree? AJ?
180 minus 104 plus 1, so 180 minus 124.
Yeah. Isn't P the center of the circle? Which means BA has to be what? What's the name of it? Starts with a D. A diameter. Doesn't a diameter split a circle in half? So the top part is 180, the bottom part is 180, which means all from B to A has to be 180 degrees. So we're going to do 180 minus 124. And we're going to get 56 degrees. So now we're going to say 56 minus 20 divided by 2. So angle C is 36 divided by 2, and that is 18 degrees. A second to finish copying. All right, last page. So I keep stepping it up a little bit more, right? So now I'm asked to find a couple things. I want to find first arc BD, then arc AB, then angle ABC. All right, baby steps. Let's first find arc BD. Is there a diameter or anything splitting this circle? No. I know there's no diameter because this is the center and there's no chord going through the center. So I know there's nothing being split like 180, 180. All right, so then I'm saying, okay, well, is there any relationship between DB and any of the angles given? Is there a relationship between DB and one of the angles? Yeah, there's a relationship between DB and which angle? Angle A, because isn't angle A intercepting DB? So now I'm going to ask myself, okay, well, angle A, is that an inside, outside, or on angle? Inside, outside, or on? On. So we're going to say angle A is equal to arc divided by 2. Now we have the angle, but we don't have the arc. So it's going to be 40 is equal to arc divided by 2. So what is the arc? Arc is equal to 80. So arc BD is 80 degrees. Now I'm asking for arc AB. Any guesses on how I can find arc AB?
Could you add 110 and 80?
And then do what?
Subtract it from 360.
Good. Isn't a full circle 360? So I have all the other parts. So what we're going to do is we're going to do for arc AB, we're going to do 360 minus 80 plus 110. So arc AB will be minus 360 minus, what is that, 190? Did anybody subtract that? What we get? I could do it, I just don't want to. Demetri? 7? 170, good. Okay, so now we got arc AB is 170. Now we want to find angle ABC. Do we agree angle ABC is another on angle? Its vertex is on the rim of the circle. So now we're going to say angle ABC is equal to the arc that it eats. What's the arc that it's eating? AB, which is 170 divided by 2. So angle ABC is 85 degrees. Okay, a few more problems, then we are done. Angle P, inside, outside, or on? Outside. Who remembers the outside formula? Kaylee? All right, so what are my two arcs that we're dealing with? Can somebody tell me which two arcs are we dealing with? Joe? Good. QR is our small arc. ST is our big arc. I have ST, but I don't have QR. Any ideas on how we can find QR? Any ideas on how we can find QR? Nora? Good. We're going to add all the other arcs. We're going to do 95 plus 85 plus 175. So 5, 10, 15. What'd you get? Say it one more. I can't hear you. 355? Are we sure? Yeah. Okay. Okay, so then we're going to do 355, and then how do I get QR? 360 minus 355, which is 5 degrees. All right, so now we have our big arc and our small arc. So angle P will equal 85 minus 5 divided by 2, which is 40 degrees. All right, do we all agree number 6, a tangent-tangent angle? What do we know about a tangent-tangent angle and its arc? They add up to 180. So I'm going to say 180 minus 127, and we're going to get 53 degrees. All right, for number 7, first we want to find arc AB. Can somebody tell me thoughts on how I can find arc AB? It's like the same 3, 4 people that keep participating. Someone show me you know something. Well, how do you think we're going to find arc AB? Well, what's the only information we're given? The only information we're given is 10 degrees. What does that mean? We have to use the 10 degrees somehow. Well, what kind of angle is that 10-degree angle? It's on the circle. And which arc is it intersecting? AB. Don't we have a formula for that? Yeah, so we have angle equals arc divided by 2. But this time we have the angle, not the arc. So 10 equals arc divided by 2. So what does the arc equal? 20 degrees. So if arc AB is 20 degrees, what kind of angle is AOB? You tell me, what kind of angle is AOB? Annalena, what kind of angle is AOB? Well, I'm not saying like acute obtuse. Like, what's the name of it? Is it a secant-secant angle? Is it a tangent-tangent angle? What's the name of angle AOB? Mia, what's the name of angle AOB? What kind of angle is it? It's not an inscribed angle. Good guess, though. And an inscribed angle is like the one here, the one that's 10 degrees, where it's vertex?
Is it a central?
It's a central angle. Guys, we've been doing central angles for a while now. Isn't AOB this central angle? Its vertex is at the center. What do we know about a central angle and its arc? They have to be the same. So angle AOB is 20 degrees. Michael, set up number 8 for me.
I don't remember which formula it would be.
So tell me, what we're finding an arc, right? So that arc has to be related to an angle. Which angle are we relating it to?
The 32 degree angle.
The 32 degree angle. You tell me, that 32 degree angle, is that inside the circle, outside the circle, or on the circle?
That's outside.
So what's the formula for outside angle?
Big arc minus small arc.
Yep, and then big arc minus small arc, what?
Over 2.
Over 2. So now plug into this formula.
The big arc is 125. Small arc is the unknown. And the angle is 32.
All right, let's go ahead and solve this. I'm going to multiply by 2 on both sides. So I have 64 equals 125 minus z. So now I'm going to subtract 125 on both sides. We have 125 minus 64 is negative 61 degrees equals negative z. Well, if negative z equals negative 61 degrees, all you have to do is divide by negative 1, and we get z is equal to 61 degrees. All right, we are done. Your homework is your worksheet. All right, those 2 pages. And you could get started now.